Lecture number 6, gradually varies flow in open channel. The first topic is the basic differential equation to explain the gradually varying flow. This is profile of the open channel flow. You can look at this line is represent the hydraulic gate line or HGL, and this line represent the energy gate line EGL. And there is a SF. SF in this case is SF bar is the slope of energy gate line. Okay, how to get this the energy gate line? We can the other one is the S naught is the slope of the bottom of the channel bottom. Okay, before we start with the energy equation, I can explain what is the SF is we can find from the Manning equation. This Manning equation, and this is we can find this is SF. So SF can be SF is equal to equal to n power 2 velocity power 2 divided 2.22. Okay, that is the SF in terms of unit of the English, not SI unit, is English unit. Okay, for the SI, for the SF, for the SI unit is there is just the n power 2 and v power 2 and power 3 for the SI unit. Okay, and next if we want to write the equation of the energy equation at this point, it's point 1, and this is point 2. Okay, so we can write at this point 1, there is the pressure. This is a pressure term to represent this pressure, plus the velocity head. This is velocity head, and plus the static head Z1. That is the energy, total energy at the point 1. At the point 2, there is the pressure as point 2 plus the velocity head and plus the elevation head and head loss. So the both side of equation is equal. Next, if we replace the pressure and elevation heads with the depth of water and S naught times delta x, and substitute the pressure heads and elevation heads at point 2 with the y2, and assume alpha equal to 1. So we get this equation 6.2. And if we assume that above equation is channel slope is 0 and it's no head loss, so we can get this equation. And from equation 6.2, if we define the energy slope as the friction slope, SF equal to SF divided by L. We substitute in this equation and we rearrange to get the x. So we got equation of x. Okay. Or we can write another form. X is equal to different energy, different between point 1 and point 2 divided by the same parameter SF subtract S naught. So this is another. Okay. In this case, E is E1 is equal to Y1 plus to G. Okay. And SF, so from the top is SF is equal to n power 2 v square that is the Manning equation English unit. And SF is equal to, and this one is from the Darcy-Weisbach, f v square is Darcy, but normally we used to explain the flow in the pipe. Okay. What is delta x? Delta x is the compute. We compute from this equation, but we have to compute for an arbitrary. We have to choose an chain in depth. Okay. And the sign of the x is negative. We got negative x if we calculate downstream direction. If we calculate from the downstream to upstream direction, so we got a negative x equal to x, and we can look at the example later, and we got positive delta x in case of we calculate downstream direction. Okay, the difference of the negatives, the sign of the delta x. Okay.